So let's do the example and see what's happening, and then some motivation. Example, very simple. Usually people like this question on the test. If I give you x squared and y squared and z squared, this is a vector field, remember? We see how the wind is blowing, or maybe gravitational forces. Find divergence of f, div, divergence. Divergence of f is derivative of x squared with respect to x. That is 2x. Instead of comma, you're adding up with derivative of y squared with respect to y, which is 2y. And then let's do z. Z with respect to z is 1. So we're adding together, and that's new. We never added up those derivatives together. So it's kind of interesting to know the motivation. Why would we do that? So, interpretation. We never had this idea before, right, so far. But this is the idea of the expansion of the vector field. Indeed, maybe you noticed or not, but fields are expanding and shrinking. You can imagine black hole and gravitational forces. These are the most interesting examples. Divergence F is that pretty cool mathematical tool that shows you the expansion of the field. And that is a pretty cool idea. So we do know gradient gives us directions and speeds. So we do know how to find potential function, which is antiderivative. That's the original flow. But how to know if something is expanding, explosion of the nuclear powered station, or the shrinking as the supernova is exploding and starts shrinking down in the black hole and stuff. So this is apparently can be done with divergence. Divergence F expands. So in this case, not sure why I had such a big gap. Divergence F is expands at the rate 3 for this particular example. Here, at the rate 3, for example. So we want to find, what does it mean? If divergence F gives you 0, then F is incompressible. Let's write this down. That's an interesting English word. What do you think is incompressible might mean? Note. What do you say?
Unable to be compressed. Not compressible.
Not compressible, yes. Very good. If divergence of F is 0, then F is called, let me put it in blue, incompressible. Incompressible. And then, just like you guys said, you cannot compress it, or incompressible. It also means non-expanding. Expanding. So not only the sign will show you if the field is expanding or shrinking, but also the strength of it. So if it's the expanding with the rate 3, F will give you that information, and so on. So that is why it's so important. Well, then we decided to introduce one more thing outside of, this example had a number actually, so let's write down. Sketch this graph. Interpretation. Divergence F means expansion. For this graph, there's actually example which is divergent of some kind of vector x, y, and z, which is also PQ. What was the other one? R, PQR, yes. PQR, for example, it was 1 plus 1 plus 1. For example, each derivative gave you 1 with respect to each variable, equals 3. This number tells you that it is positive, it's expanding. How fast it expands? It expands at the rate 3. So number will be important, how large this number is important, sign of it is important, and if it's 0, then it's not expanding, not compressing. Yes?
Can I see the example above the graph real quick?
That was just to calculate, to be honest, just like random calculation stuff.
Okay, thank you.
Not very interesting, to be honest. So, did you guys think the review I gave from home helped you?
Yeah.
So, I will give one more review for the final exam. I just distracted myself with this idea. Don't be afraid about that. Final exam will be challenging, covering all of this new stuff plus the previous stuff. But I will give very nice exam review when I have the exam in my hands. I will give exam review, and we're going to prepare for 2 hours. I will be preparing you, and then I record it so you can review it as many times as you need. Why so many questions about that? Yes?
Are
are you gonna open up the previous characters?
Everything, yes. Everything you want, I will do it, yeah.
Do you know what the ratio is going to be
What
for
ratio?
material on the?
No, but probably new one more than old one, yeah.
Did you say that the final grade was our lowest exact grade?
Yeah, if you do well on final, since it's cumulative, it's common for us to allow to use the better grade, to substitute some bad grades before you had, maybe you were sick that month, or maybe you just moved to Arizona, so it makes sense to allow this. That's a good thing to do. Also, evaluations open to this class. Don't be lazy, go submit some 5, right? To be honest, evaluations are important. I just submitted my documentation for the promotion and we put our evaluations there. This is the first proof that we're doing a good job. And since it's anonymous, it's not biased. So, go submit something nice. If you'd have concerns about the class, you can always talk to me, right? But when it comes to official documentation, be careful with that. For all instructors you submit, it's very important. That's how we get a raise, and that's how we get paid. We had higher salaries. I have higher salaries because my evaluations are good. Motivation for the curl. Let's do some curling, like a ballerina. No. What is an analog of Q with respect to X minus P with respect to Y in 3 dimensions? People ask me about this. We're gonna slightly touch this topic and then we never go to the Stokes theorem, unfortunately, but it's fine. Suppose F is conservative and we know what does it mean? But let me remind you, that is, this function F exists. We found it. It's called potential function. We found it. So P, Q, and R will be a collection of those F's differentiated with respect to corresponding variable X, Y, and Z. Conservative. We remember when we started learning partial derivatives, there was a Chlorate theorem that was saying that these guys match. Derivative with respect to X, Y, and YX, Y, Z, Z, Y, X, Z, Y, Z. You don't have to write this down. This is just motivation, how it happens. So for good curves and good shapes, that happens. So when you calculate all of this, these gave us equations, and these equations will be used to create an amazing operator. It's called operator. Actually, I probably should define what operator is, maybe later. It's called a curl, so write down this. Operator called a curl that takes care of all 3 cases at once. So, unlike the previous case, there was a number or a function. This one will be a vector. A curl is a vector, and the formula will look like this. Let's write down the formula in red. Curl. Curl is a very well-known operator, and that's why it's given a name operator, because it's very important. The operator has upper-level math notation, which is basically a cross product. Cross product is a vector product, if you remember, of the gradient and your field. That is a shortcut notation of what it is. That cross product, do you remember how we create cross product? It's a determinant of the matrix, right? So determinant of the matrix is I, J, K. That's how we learn it. That's what vector product is. Vector product. That's how we call it in Russian, vector product, which makes sense because it gives you a vector. But we call it cross product. Cross product. I, J, K, that's how we're building it. Now, at the very bottom, you put your favorite P, Q, R. And then in the middle, derivative with respect to corresponding variable. The first will be partial derivative with respect to X, partial derivative with respect to Y, partial derivative with respect to Z. For you will be unusual to see that I'm not writing down what derivative of what. That is a common notation, because when you actually perform products, remember how we do products? If I do I will cross these two and then cross product these. So it will be derivative with respect to Y of R minus derivative with respect to Z of Q. That's how you're going to do it. Next one, and next one, and next one. So after all, it becomes this. It's a vector, remember that. Let's see. R differentiated with respect to Y. You see my arrow goes like so. Minus Q differentiated with respect to Z. That one goes first because it's corresponding to I. Second one, there's a second one. I cross x differentiation goes to r minus p differentiate with respect to z. But I has a negative sign in front of it, remember? So it will be minus what I just said. So we need to flip the order, which is going to be p. Let's do it like so. P differentiate with respect to z minus r differentiated with respect to x. I will write down here it was minus rx minus pz. So that's what happened. I switched the order because of that. Because j variable switches to have a negative sign there. Finally, the last one, k. K will be q differentiated with respect to x minus p differentiated with respect to y. Let's write it down. It's going to be q sub x minus p sub y. Wow, so easy to memorize. Yes, so people struggle with memorizing this order, but from the determinant you can derive it. So I never memorize it. I always derive it from scratch. It's too complicated. Always afraid on the test I will blank out and mess them up completely. So I choose to derive it every time. And how do I do it? Just like I showed you, I only memorize the determinant and then I derive it from scratch every time. Because now you know, this notation is so popular to put derivatives separately, but you never indicate derivative of what. And then when you multiply, this becomes derivative of that. So that's very common notation actually. Yes?
Why is I negative again?
Remember? Plus minus plus, plus minus plus thing.
Oh.
That's why. So 1 should be negative. Moreover, it becomes like this, minus, plus, minus, and so on. So it's always alternates. Yes, alternates. Okay, now you can imagine what the exam's questions are going to be. We're going to give you amazing interpretation of all of this. But after all, we will be just asking you to find curl and divergence, curl and divergence. So let's do it. Example. Find curl. Find curl f where f is 0, minus z, and y. The more complicated the function, the more complicated it becomes. So let's do the simple example first, and then you struggle in your homework. Haha. Well, you know how it works. Solution. But you have good forum, so definitely check the forum. Curl of f. So again, without seeing a formula above, I will just build a determinant. I remember how it works. I, j, k. I remember it's p, q, r, like in the alphabet, right? And then it's derivative with respect to x, y, and z. So derivative with respect to x, y, and z. dz, partial derivative, right? Partial derivative with respect to z. Now, I just need to remember that p, q, r, how should I will be like messy, like so. P is 0. Okay, probably you will not get it like this. P is 0, minus z, and y. Just plug it right away. P, q, and r. First, second, and third one. Doesn't matter what is there, you put it in order. And then either you remember this formula, which I can put in the box. If you're good at memorizing things, then good job. I always jealous people who can. But I cannot, so that's why I don't take physics major. Or chemistry. In math, you can derive most of stuff, and that's why it's so pleasant, because it works. So it's going to be a vector. Remember, the answer should be a vector. If you get a final number, you messed up. It's not dot product, it's a vector product. So a vector, the first component is I multiplied by plus. And then I'm imagining in my mind this cross product. So it's going to be derivative of y. I will only once will write down slowly. Derivative of y with respect to y. Right? Nice. Times derivative of minus z with respect to z. Nice. That was the first component. Comma. Second component, let me put in blue color.
Why are you multiplying?
Yes, good choice. Good point. It's minus, by the way. Yeah, minus. Now, minus in front of this stuff, or switch the order. I don't think you'll remember switching the order. So put minus because of the plus minus plus formula. So minus goes first and open parentheses. I am imagining crossing these off, like you're bombarding them, they disappear. Now, y is multiplied by derivative with respect to x. So it's going to be y, let's put it like so, prime, but with respect to x, that is 0. Minus 0, whatever, derivative of 0 is 0. So that is a good one. And the last one, comma, let's put it in a new color. The last one is green. Did I do correctly? Yes. The last one is these two. K gives you minus z, but differentiated with respect to x, times minus 0. Anyway, writing this down step by step is harder than actually doing it right away. I think so. So, because you just differentiated your mind really fast, and you guys are good in differentiation because a year and a half you took a mastery exam. Think about that. There was a mastery exam. Maybe you did not take it if you was not at ASU. About chain rule and product rule, right? And now look at that, how far you came. Look how far you came, people.
Oh, yeah.
How far you came. It's crazy what we do here. Look at this. After struggling with chain rule, you're doing this. How cool is that? I'm very proud. Honestly, the progress is amazing. Only a year and a half and you do this.
You just love seeing us grow.
Right? Y prime with y is 1. Z prime with z is 1, but it's minus, so plus 1, comma. Y prime with x is 0, minus 0 is 0. Z prime minus z prime with x is 0, minus 0 is 0. So the vector becomes, it's a vector, remember, not a number. 2, 0, 0. Very interesting. Vector, not a number, so make sure it's a vector. And because divergent f was a number, but let me write down note. Divergence f is a number, while curl is a cross product, so it's a vector. It's a cross product. Good morning. So that's how you do it. Interpretation. But let me ask you a question about technical stuff. How do you feel about it? Yes.
So, for the J component, you put a negative across the whole thing because the derivative with respect to x, right? That was negative?
No, because in the matrices, it's a matrix formula. Matrix. If you take a class when they teach you matrices, they explain you that when you find a determinant 3 by 3, and actually upper division also, it's going to be always alternating sign. You just keep changing it. So any other signs around you should be different. Plus, minus, plus. And if it's higher dimension, you do the same thing. Say it's 5 by 5. I worked in my master's degree with 5 by 5 matrices. Plus, minus, plus, minus, plus, minus, plus. So you just literally playing a game with this, and that's how you know the signs. You do the sketch like this, and you don't forget to change it every time you multiply. Like so.
I just realized why. Because my question was with the z, but I see it right. Negative times negative.
Oh, it was a different question.
Yeah, I didn't notice that. Yeah.
Well, good job, you figured it out. But now you know also this one. Yes, z was also negative, yeah. Z was negative, and this was... Anyway, you got it. Good question, I guess. Cool, so let's do some interpretation. Oh, more questions? Did I miss someone? Technical stuff, you practice a lot, you define. Intuitively, curl measures the rotation of f. Write this down because that is a pretty cool idea. Not only divergent measures the expansion of the field, curl measures rotation. And that's what we never did. We never did these things. We kind of learned how much work is done by the field when you was running on the track and the wind was in your face or behind you or perpendicular. We did that. But how much rotation does it give it to me? Does it have expansion? Maybe it's like dragging my hands to the sides and gonna blow up the body, right? So Very interesting. Mathematically, we never came to the moment until now to figure out mathematically what number or what derivative or what collection of derivatives will show me the rotation of something and expansion or shrinkiness of something like a black hole. And that's, as you can guess, derivatives. That's why derivatives are so important. They are the one who show all of this. Changes, but how? Sideways towards inside and rotation. So recall, we already measured before that microscopic rotations were shown in 2D by this difference. Q differentiate with the other variable x minus and so on. You did it on a test. If it's not 0, it's actually not good, because then there's some kind of small rotation happens. Small rotations collect into big rotations, and that's not good. Curl, we do that thing in 3 dimensions now. Curl is, we just wrote down the formula, so that's nothing new here. And it shows you something like that. Maybe sketch a graph. This is how I would do it. So 3-dimensional x, y, and z. Rotations at this side is this difference, pz minus rx. P with respect to third variable, r with respect to first variable. This rotation happened on the floor. Those are 3 different directions, right? Qx and minus py. These rotations is shown by this component, and this is a vector, right? So each component tells you some kind of story. What kind of story? So this one is over here. Let me not add more arrows. This one is over here. This one is over here, and the last one is at the bottom. So each component tells you some kind of story. If it's large or small, you know the rotation with respect to the floor, but maybe in the air. So maybe there's some kind of wind happening at the floor, and that's how the tornado is created. But then it kind of disappears upstairs because of the air pressure. So this is what curl of f is. Pretty fascinating. The curl measures how f rotates, but in each plane. In each plane. Yeah, I will wait. And I will show you the examples, and then we're going to figure out some example too.
Do you have any cool videos?
I found the animation I showed at the beginning, and I'll try to find more, but surprisingly not so many. I found this one, right? Rotations and how it changes the shape of the object. And you see, this is still 2-dimensional rotation, to be honest. So we are talking about 3-dimensional. How cool is that? We did see these before. Let me see. We saw these before, but it's not very rotational. So I was curious about that, vector fields, okay, rotations. But I don't see anything beautiful in 3D. I wanted to see something in 3D, but not really. Maybe here? No, it's still dropping a ball to see where it goes. So I will look later more. I was kind of disappointed. I thought that they should be here right away. Oh, maybe this one? Nope. So that one was, I guess, the best one I found.
So we put 3D in a circle.
This one, you know, how it stretches, how it shapes. You guys should create this. You know how to code. Then you will contribute, you know, in future classes I'll be showing your stuff. That would be so cool. Ike, looking at you.
See that? I'm not sure how it works.
When you have free time, code some nice animations for math teachers.
You should put 3D in the search bar, Professor.
Do I get extra credit?
I think we can do like an honors project about that, which I'm completely behind, but still. So interesting, I'm showing these animations in my talks to show other instructors, and they are so skeptical about this. They're like, oh, animations, why do you need that? I'm like, really?
Yeah.
But animations like help visual learners so much. I'm so envied that I did not have them when I was a student. And apparently I'm the one of the few who do that. But it's so cool. I don't know why people are so not optimistic about this. Yes?
I was saying you could add like in 3D space in the search bar, maybe it'll do like 3D.
Yeah. I would imagine like a tornado shrinking here but stretching here, getting slower over there, that kind of thing.
Yeah, that's what I was saying, like maybe you could find something like that. You search it.
Oh, that's what you mean? I'll do it later, yeah. Yes?
Does curl work for 3 dimensions, or does it work for any number of dimensions?
It will go upper dimension. Yeah, good question. That's gonna go upper, yes.
That's best.
So, let's move on. and do the example. Here's the example, write it down. We did 0 minus z and y, and we found that the curl was 2, 0, 0. What does it mean? It means that if 0 and 0, so let me go and check again. Let's see carefully. The second component shows you this vertical plane. The last component is the floor. Okay, so if the last two components are 0, there is no rotation on the left and on the floor. No rotation here, right? So like, I'm not doing anything. No rotation here, but it has rotation with strength 2 in this plane. It's rotation over here, smiling, right? So that's kind of, or maybe like surprised. Yes, that would be surprised. Whoa. Right? So like that's the idea. I don't know. If you understand this joke, I'm not sure if you do. So that is my idea. So this each component tells you what is happening. No rotation. Rotation with the strength 2. No rotation, no rotation. The curl F in the axis of rotation of F. So sketch this. Can you sketch that? And let's do some more examples. Yes?
So when the curl is like in this example, the number 2 is in the x component, does it mean like the object is rotating around the x-axis, but with the center of axis being the x-axis?
Good question. I would say it shows you both the direction and strengths, but away from the plane when there's nothing here. Yeah, that's a good question. Let's do more examples to get intuition about this. Yeah, his question makes sense. Like, does it mean we're not rotating towards there? But rotation is 3-dimensional. So I would say,
well, I was wondering what
it's like location more than the direction. So it's not in that plane. So it's 0 rotation in that plane and on the floor. But there's a rotation in the first kind of plane up and down, right? Yeah.
Then that would be the rotation is happening in the YZ plane though, right?
YZ. Yes, I think so.
But the component is in the...
Oh, doesn't matter. You see, they do not match really well about that. The first component is actually about this guy. This component about this plane and this component about that plane. So they don't really match well when it comes to that.
So they're just random?
Not random. They came up from this. They came up from this determinant. Determinant was very structured. Determinant was has a nice structure. IJK, PQR, XYZ. But when you start multiplying the determinant, they start cross multiplying, and that makes a kind of flip of what is happening. YZ, ZX, XY. You see? So they all kind of RQ, PR, and so on. That is the interesting part. Moreover, every time you do these calculations, you see, the first component completely disappears when you do the first product, right? And that is why the first component completely has nothing to do with the first component P. So, here on the picture, yeah, it's a good question. This 2 has nothing to do with the first component P after all. This 2 is actually about this one, Z and Y. Why? Because in determinant, you have to ignore the first component when you do the cross product first. Makes sense? I, J, K. The first component over here, but the moment I'm calculating the first one, I'm actually ignoring it completely. So P, Q, R, Y, Z were involved for the first component to be created. There's no X there, and there's no derivative of P.
So the first component of the curl, so the X component of the curl describes the rotation in the
YZ plane. Exactly. Yeah. Because how we create matrices and how we calculate determinant of the matrices. Yeah. That's a very deep question. Yes.
So does that mean we could look at it as like a torque or like a moment?
Very cool idea. Torque and moment. I guess so. I can research that. That's more physics. So.
Like, I know because in statics, like you use the J and K components to find the moment along the x-axis, right? So like the spin on that.
Yeah, I know what you're talking about. I will look up on that. Yeah. The moment and stuff, I remember briefly learning this in partial differential equations, so I can check it out. Yeah. Yes.
So the positive value of the first component implies counterclockwise rotation?
Yeah. You will see examples when it will be the other way. Yes, very good. And that's why when you have different signs, you know it might create some turbulence and stuff because they go towards each other, so that will be pretty cool. Okay, conservative vector fields. The most important thing about curl is that it gives us a very elegant way of checking whether a vector field is conservative or not. If the curl gives you all zeros. Remember, zeros means no rotations. So, conservative vector fields are irrotational. We know that from before. That's why it's nice to have all those zeros. Then the field is safe. It doesn't drag you into the black hole and so on. It just goes to the left, right, up and down, I don't know, whatever you want. But at least it's not swirling. Because again, having rotations are difficult to explore. It's sines and cosines. Polar equations, spherical equations are all connected with these rotational movements in the air. And that's why aerodynamics is so complicated. And that's why black holes and gravitational force is so complicated. That's why tornadoes are impossible to predict up until like 3 minutes it's too late. And so on. Because math here is really hard, as you can see. But the good ones don't have any rotations. And that's what we call conservative fields. So here's the interpretation. You don't have to remember. You don't have to write this down. You'll have it in your notes. If curl 0, 0, 0 and no holes, then F is conservative. And this uses Stokes' theorem, which we don't really cover in this, unfortunately. So, but it's pretty cool, though. It is pretty cool. Write down this. F is conservative if and only if. That means it goes both ways. If curl gives you 0, 0, 0, conclusion, F is conservative. And vice versa. If F is conservative and you already know that, then you can assume that curl gives you 0, 0, 0. No rotation in any plane. This is a good test for conservative in 3-dimension, analog of what we had before. So let's do this in one more example. This is a good exam question. As you can see, multiple choice. Check if this field is conservative, but in 3-dimensional now. But then how do you check? Now it's not just that simple. The first one with respect to the second one and they should be the same. Now you have to actually build a determinant and that kind of stuff. So it gives you more steps now. Solution. Let's figure this out. Did you finish writing down? I will start writing down curl F. Yeah, that's why I'm keeping it up. I actually will just lift it up like so. So let's start writing down curl F solution equals, and now you create a determinant, unless you memorize the formula, and the formula I'm talking about is this. Maybe you can rememorize it, I don't know. Then you just don't have to build a determinant at all. Qx minus py, check if it's 0. Arc y minus qz, check if it's 0, and so on. I will build the determinant. So I, j, k, p, q, r. Do we have to write down p, q, r? Let's just write down the functions right away. Y squared z cube. Leave some space not to mess up your brain because it's too many variables over here. So keep stretching it, keep stretching it. Make good notes. People who work with matrices and data science, by the way, they know that having good notes will make difference. If you mix up data together, numbers and variables, you will mess up the result. So you see, this is a nice looking notes. They're separated, you can visually see the difference. Derivative with respect to x, derivative with respect to y, derivative with respect to z. Let's do it. We are curious if it gives us 0, 0, 0. That is the idea. Maybe let's write down the goal is if it's 0, 0, 0 question mark. That is what we're doing here, right? So let's check. Do you understand how I'm going to be checking this? I'm multiplying these two first, cross. Derivative of 3x y squared z squared with respect to y. Do you see what I'm doing? This one first. With respect to y, look how your brain should like identify this piece. That means y is a variable, everything else is a constant. So 3x z squared is a constant times 2y. Did you get it? Did you get any of this? Rick and Morty, famous phrase. Did you get any of this? Now, minus this, minus derivative of 2xy z cubed with respect to z. 2xy are constant, z constants. Z gives you 3z squared. Did you get this part? comma. Is it 0? I don't know. Let me check. 3 times 2, 6x z squared y. 3 times 2, 6x y z squared. Same thing. Nice. So we already have first 0, but we still need to have all of them. But at least now we know there's no rotation for the first component. Cool. Now, second one. So I'm kind of erasing these two. Second one is the one that's hard to visualize because it's kind of scattered. This one. Derivative of, maybe if you say it out loud for yourself, it will be easier. 3x y squared z squared with respect to x. What is the constant here? 3y squared z squared. X is the only variable. Let me put it in pink. Derivative of x with respect to x is 1. Minus. Did you notice I missed something important?
The minus.
Yeah, the negative.
The minus right in front. So keep this in mind. Either flip the order, which I think you will not remember, or you put minus in front of the whole thing, like so. Because of the formula of the determinant. Minus this one. Y squared z cubed. With respect to z, the constant is y squared. Z cubed gives you 3z squared. Is it the same? Does it give you 0?
No.
I don't know. Let me check. Let me put it not in parentheses, but in brackets. And there's no vector here. Why did it put that? Comma, comma. This is my second component. Minus 3y squared z squared minus 3y squared z squared.
Plus.
It's plus, right?
Yeah, so I can't.
So it is 0.
So,
Nice. Because of these brackets. Because of these brackets. Anyway, thing inside is 0. So whatever negative, it doesn't matter. Finally, the last one. The last one, let's put in the blue color. It's going to be these two. 2xy z cubed with respect to x. Everything is constant except x. 2y z cubed derivative of x with respect to x is 1. Minus is always a formula. I'll put it in green again. And then in blue color, these two. Y squared z cubed with respect to y. Z cubed is a constant. The last derivative is y squared with respect to y is 2y. And you finish the vector. And now you just have to hope that it gives you 0 zeros. Then it gives it conservative. Check the first one, we check the second one. The last one is 2yz cubed minus 2yz cubed. 0, 0, 0. Amazing job. It says bingo in the notes here. So the answer is yes. Answer. Yes. It is conservative. Conservative. So careful, different. You see how far did you come that we have to deal with 3y squared, z squared, x squared, differentiating with what kind of variable? I'm telling you, every time it's different. Your brain have to keep switching. It's like a complicated puzzle or a game. And now, the next question, so that was A. Question A. The next question, B, is, well, if it is conservative, what does it mean? What can we find? Potential function f, which is a potential function, which is basically antiderivative function, any, right? Because there's super many of them, such that as t, that's what you had on your exam, f is just collection of derivatives of this small f. Yeah, how are we gonna do it in 3-dimensional? Just like we learned before. You integrate each with respect to each variable and find the solution. And we're gonna do it on Monday.
Yay. We don't have class on Monday.
I'll make a recording.
Yeah. It's not the same still.